Hey guys, in today's video we are going to solve one more LeetCode question, that is question number 31, next permutation. This question might seem to be easy at first, but it isn't, and this has been asked by so many organizations. So it has been asked by these many organizations, and at first it might seem easy, but once we start approaching towards the solution, we will realize that it isn't. And I will make you all understand why I'm saying like this. But before that, let's just understand what the question is all about. So in this question, we are given a array, nums, and we are asked to return the next permutation of that array. So if we are given an array as 1, 2, 3, so firstly we have to see what all are the permutations, and then we have to return the next permutation. So this is the example, and as we can see that our input is this one, and the next permutation to this one is this 1, 3, 2. So this will be the output for the input 1, 2, 3. So this question might seem easy, like firstly we will get an input and we will create all the permutations, and then we will figure out which will be the next permutation according to the input, and then we'll return it. But we know that the input size can be from 1 to 100. So in this case, we know that permutation is going to be n factorial, right? If I'm saying my n is equivalent to the length of nums, so in this case it will be 3, and 3's factorial is 6. So there will be in total 6 permutations of this array. But if the nums length is equivalent to 100, in that case we know that calculating all the permutation is going to take really long time. So we know that we can't approach with this brute force approach where we are going to calculate all the permutations and then we'll check for the next one and we'll return it. But then how we are going to solve this question, right? And we are not only going to solve this question in one programming language, we will be again solving this question using 2 programming languages, that is Python and Ruby. But before that, let's try to understand what will be our approach and how we are going to solve this using that approach. So for that, firstly, we'll consider this as an example. So if I have to see what all are the permutations, as we had already seen in the question itself, that all the permutation for this input is something like 1, 2, 3. Next will be 1, 3, 2, and next will be 2, 1, 3, then 2, 3, 2, then 3, 1, 2, and 3, 2, 1. So these are the 6 permutations. Now we know that every time input is not going to be this simple, right? It can be a complex one. But how we are going to calculate the exact next permutation in that case? So in such questions where we know that there will be many scenarios but we only have to concentrate on one, in this type of condition, what we do, we firstly take a small example, like in this case we took 1, 2, 3, and after this we will start observing the pattern. So we need to understand, is there any breaking point in these patterns with which we are going to create our own approach. So for that, what we can do is, firstly we'll observe these permutations and we'll try to understand what all things are repeating and how we can identify where we have to just shuffle up these numbers in order to create the next permutation. So as we can see, first thing very clearly, that the first number, the first permutation and the last permutation are reverse of each other, right? And first one is in completely ascending order and it is the smallest permutation, and the last one is in the descending order and it is the greatest permutation of this combination of numbers, right? So this is first thing that we observe, that the smallest permutation is always the one which is present in ascending order, and the greatest one will always be in descending order. And the first and the last permutation will be the reverse of one another. This is first thing that we observed. After this, what we can see is, the second point that we can see very clearly is, if we make any change in the right side of the permutation, then it is not going to impact that much. So in this case, if I am seeing 1, 2, 3 and 1, 3, 2. So in this case, we know that the last two places from the right end are swapped, right? Last two elements are swapped. So if I'm going to see the difference in these two numbers, it is not that huge, right? From 23 to 32, it is not that big difference. But if I'm going to see 2, 1, 3 and 3, 2, 1, in this case, I'm seeing that these numbers, the number which is at the leftmost place, this is the one which is changed. And when I'm changing the leftmost integer, I can see the difference. The difference is greater than 100. So if I see the difference, then in this scenario where I just observed that the rightmost elements are being changed or shuffled, in that case the difference that I'm getting of is 9. And if I'm making any change in the leftmost elements or numbers, in that case the difference is huge. Now, as per our question, we need the next permutation. If we have to calculate the next permutation, then definitely the difference won't be that huge, right? Difference will be that huge if we are looking for a permutation which is way after the current one. But if I'm saying I just want the next permutation, in that case I know that I want the one with the least difference, or which will be the next greatest, in other words. So in that case, I know that the difference won't be that huge. So from this observation, what we figured out is, we'll be making change, or we'll be performing all the operation from the right side, rightmost index of our input array. So this is what we observed, that we are going to perform all the functionalities from right side. So these were the two observations that we got from this input. Now let's try to apply these observations on another input, which would be slightly complex. So we'll be able to understand like how we can come up with the exact solution. So let me first just clean this board and then we'll see that example. So this is the new example with which we will understand and apply our previous observation, which are these two. The first one is that it is in ascending or descending order, which will tell us that this is the smallest permutation or the greatest. And if we have to perform any sort of functionality in order to calculate the next permutation, then we are going to do it from the rightmost index. So these were the two observations. Now let's see in this example firstly what we can observe, and secondly how we can apply the previous observation in order to achieve our resultant, right? So if I'm going to see this example, I can see very clearly that 1 and 5 are in ascending order and rest of the array is in descending order, right? So if I have to find the next permutation of this input, in that case what I will do is, firstly I know that whatever I am going to do, I'll be doing it from right index. So if I have to make any change, what it will be? Firstly, the lexicographical permutation of this input will be just next greater number after this. Just next greater number after this means if the number is starting with 1, 5, then next will be greater than 5. So if I'll see the rest of the array in this, which is the next greatest number than 5, it is 6. So our resultant will be somewhat 1, 6 and then rest of the integers. So how we are going to get it? So firstly, what we need to find is, we need to find the index that we need to index at which we have to replace with the next greatest. So right now this number was 158653, and firstly what we observed is this part is in ascending, this part is in descending, and if I want the next permutation of this number, then I just want the next greatest number, closest greatest number of this permutation, closest greatest combination of this permutation. I'm constantly saying numbers, so just don't get confused with that. I only mean permutation. So what I'm trying to say is permutation. So the next permutation will be somewhat like 1, 6 and so on. So firstly we need to check this breaking point, right? Like right now we are able to see with our eyes that 5 is the breaking point after which the whole array is in descending order. But in general, when the input is being given, how we are going to calculate this thing? So for that what we can do is we can use 2 pointers and we can start traversing from this rightmost index, and we will traverse it, and then we will traverse in this direction and calculate this point at which our condition won't satisfy. Which condition? Like we can see if it's in descending order, then if I'm saying this is my I, then this will be I plus 1, right? Index. And to check this condition is true or not, what I can simply say is, if the element at I is greater than I plus 1, then simply move in this left direction and keep decrementing our I. At this place, this condition won't satisfy, right? So I know that now my I is at that position where I need to make a change, because this is the number which I am going to change with the rest of the available numbers in order to get the next permutation, nearest greater permutation, right? Or just next permutation. So this is the first traversal that I'll be doing, and I will be achieving this target as the breaking point. So now my I is at the breaking point. Now my I is at the breaking point and I want to know with which number in the rest of the rightmost index I can replace among these numbers, which will be the next number with which I can achieve my target or I can obtain my next permutation. So again what I will do, again I will traverse this array from rightmost index and I will call it as J. Now I am going to check whether my J is greater than I or not. So firstly I will compare 5 with 3. I know that 3 is not greater than 5. So I won't be able to proceed with 3. So I will reduce my J and I will go to 5. I will check this. No, 5 is equivalent to 5. So again I will come up to this place and I know that 6 is greater than 5. So I know that I can proceed with 6. So I will break this traversal and now my J is at which place? This is the next permutations number. So now I am having I and J, and what I am saying, the next permutation will be with 6. So what I will do, I will simply swap these two, 5 and 6. It became a bit messy, so let me just write it down here. So what will be the case is 1, 6, 8, 5, 5, 3. So this is the current state after swapping my I and J value, right? So now we can say our permutation is a bit different from what we got and it is greater. But is this the next permutation? So no. Why? Because if we see 1, 6 is fine, but this part, this part of the array is still in descending order, right? So what I can do is, I know my I is still here, and I know that the rest of the array after I is still in descending order, or is not in the ascending order with which I can achieve the smallest permutation. As we already seen with the first example, that if we want the smallest permutation or the next most permutation, in that case we need to check that the whole permutation is to be in ascending order. Else, if it's in descending order, then we are having the greatest one. So what we will do now, we will simply reverse this part of the array, and our resultant permutation will become 1, 6, 3, 5, 5, 8. And this is how we got our answer. So this is the actual result that we were looking for. So with these two observations that we made with that example, and after again observing the pattern in this example, we came up with this approach. I know this wasn't a straightforward question, but we can't help it. This was the simplest way with which I was able to explain, and I hope you all understood this. And if not, that's not an issue. You can again watch it from starting. And even while we will be coding the solution, I think that you all will get exactly what we are going to do. So first thing is, we want I, then we want J, and then we are going to swap and reverse. So we used 2 pointers on this input and solved our question. So this question was solved by 2 pointers approach, which wasn't that easy to come up with, but at the end we got it. How we came up with these 2 pointers, why we came up with these 2 pointers, and how we made peace with these 2 pointers and got our answer, right? But now there is one more edge case that we hadn't talked about, which we'll be checking after calculating I. What is it? What if our input is somewhat like 3, 2, 1? So if I'm going to see this input, I know that this input is already in descending order, right? So this is the greatest permutation. After this, we can't get any permutation from this combination of numbers, right? So we know that this is the last combination. So in question, it is given if this is the scenario, then we simply have to return the smallest one. So what will be the smallest one? Reverse of this one. That will be 1, 2, 3. Just because of space constraints, I'm writing it down here. So this will be the answer in that case. So while we were calculating I, we were traversing from right to left, right? So in that case, if this is the scenario, our I will become 0 or will become lesser than 0. So we know that I is gone out of bound. So in that case, we know that the whole array is in descending order and is already in the greatest permutation form. So in that case, we will simply reverse it and return. So this was the edge case. Now if I have to talk about the time complexity of this whole approach, then time complexity, I'm writing it up here. Time complexity is around big O of n, because we'll be traversing this whole array. At most, we will be scanning this array twice. We can say that will be the case in worst case scenario. So time complexity will be big O of n. And space complexity is big O of 1, as we are not using any space and we are not even allowed to use any space, because this question itself said that we have to do all the changes in place, and we had done these changes in place only, because firstly we find out I and j, and then we simply swap those integers and then reverse this much part of the array in place. So space complexity, why I wrote big O of n, it is big of 1. Big of 1. So this was the time and space complexity, and I hope this explanation was understandable. Now let's go to the coding part. Okay, so as we had already seen in our drawing explanation, we need firstly I. So what our I was? I was length of nums minus 2. After this, we have to check the breaking point. So while I is greater than equivalent to 0 and nums I is greater than equivalent to nums I plus 1, what we will do, I minus equivalent to 1. After this, we will check for that edge case. If I is greater than equivalent to 0, then only we will proceed, else we know that we are having a we are having our array in descending order. So if it's not in descending order, then only we will come inside this if case, and what we will do is we will simply create j, that will be length of nums minus 1, and again we will run a while loop where j should be greater than equal to 0 and nums of j is less than equivalent to nums of I, and we will again subtract j. After this, nums of I and nums of j are going to be swapped with nums of j and nums of I, and then we will step out of this if condition. What we are saying is nums I plus 1 will become nums I plus 1 colon minus 1. So this has been reversed, and then we will run and check if I had made any mistake. I hope not. Okay, so this has been accepted. So this was around, I guess, 10 to 12 lines of code, and it took really long time to understand the whole approach. Now let's code the Ruby code. Same thing we'll be doing here. Firstly, we'll be getting our I, that is nums dot length minus 2. After this, a while loop where I will be greater than equivalent to 0 and nums of I is greater than equivalent to nums of I plus 1. Inside this, I minus equivalent to 1. After this, we'll check if I is greater than equivalent to 0. In that case only, what this habit of adding semicolon is because of Python. So inside this, what we were doing, we defined j, and it is nums dot length minus 1, and we again ran a while loop for that. Nums of j is less than equivalent to nums of, and then we are going to do this, and we will be swapping nums of I, nums of j with nums of j and nums of I, and outside of this loop, I plus 1 to minus 1, because this is not Python, so we can't use string manipulation. We have to do it in this manner. Let's try to run this and check if I hadn't made any mistake. So I did something. Okay, so I did the same thing which I did in the last video, if you had seen my video. Then again I wrote this return is statement inside this if condition, so this has to be outside of it. I think if you're working with Python, this is pretty much an issue because we are not habitual of this endings of loop and all these things. It's just indentation and we know that it's done. But yeah, we are learning new language, so it's okay. Now let's submit this. Today my throat is bit, I hope it hadn't hurt your ears, but please bear with it. So this is also accepted, and this was the question that we solved today. And I hope that this whole video was useful for you all. And honestly speaking, after solving this question, I really felt bad for all the poor souls who got this problem as an interview question, because this is not that straightforward question, but kind of layered one. But as soon as we start getting those hints from observations, we know how we have to proceed with this question. But yeah, if in an interview I'm going to get this question and I hadn't seen it before, then it's quite difficult one, because we just right away can't come up with any sort of approach at that point of time. But I hope that this video was helpful for you all, and if you really find it helpful, then you can like this video, subscribe my channel, and I will soon come up with few more such questions. Till then, take care and keep messing with algorithms, and thanks for watching.